Okay, this is a small little explanation of the Backus Naur form. Um, so let's just get started. The definition of the Backus Naur form is that it is a language that enables you to specify legalities in any language, whether it's human or computer language. So it's you can use it to define your either English or even a programming language like Java. So basically, it's a language that defines the rules of another language, and we'll see how that happens a little ahead. So the purpose of the Backus Naur form is that it is a way of conducting lexical analysis. And in class, we will explain that there's another way as well, but this is a better form according to Ingrid. Um, Lexical analysis is the first step in the compilation of any code that is required to run as a program. So basically, it's just a step, and the Backus Naur form is a way of conducting that analysis. So regarding compilation, what is the definition of compile? It is the translation of high-level code into machine language. So that's pretty much all you need to know as far as the origins and the implications of this in computing go. So move on. Now this probably looks familiar to you. Backus-Naur form divides any given language into a bunch of different things. Token, lexemes, and patterns. I'm not going to go into this very deeply because, well, for one thing, we've been told that we are not required to go into this deeply. So that's one thing to note. But it's good to know. Still going over this, there is now I'm just quickly going to jump through what a relation is because, um, well, I think it's not. I can explain it. So, of course, these are also it's simple. Basically, a token, lexeme, and pattern as far as while and if go are pretty much the same, but we're not going into that. So, it was mentioned that this what I'm circling over here is oh sorry is an or. So these are all relations. So the option is less or more than or equal to, or this exclamation with an equal to sign means not equal to. So that's a relation basically. So you can have x is more or less than y, or in this case, if you have x on the left and y on the right, you have x is less than y, and on the other side you can have x is less than or equal to y, whatever it may be. And if you have an x over here and a y over here, it means that x is definitely not equal to y and vice versa. An identifier, I'm not going to explain what an identifier is, but basically it's a bunch of characters put together. Now, how that's defined is through this way. And I'm going to move on to the next one. As you can see, we have plus and star as as superscript over here. So that's important to know. We'll go into that in the next slide. The plus means that the first number in a sequence may start only with one or more. So basically, a number, the number specified in brackets, it cannot be zero. It has to be either one or more. And I've explained that over here by showing that there is this range over here. So 0 to 9 basically it implies numbers. Okay, not necessarily between 0 and 9, but it just implies the entire number range. So that's what you get: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that's all you have in the single digit field. So you move back to 0 and start again. That's how it works. So the plus implies that x is equal to or more than 1. So basically, you can have any number, you can form any number regardless of what it may be, and as long as it's not 0. So that's one thing. Next thing is star. A star means that the first number in a sequence may start with and even be 0. So therefore, in this case over here, it's x is equal to, sorry about that, x is equal to or more than 0. So basically your number can be 0. Now there's no point to really putting in a 0 before a bunch of numbers like say 0, 5, 6, 7, 8, because well, that doesn't really make sense. It doesn't fit any kind of method. So that it really depends on the rules, and there's many different kinds of BNFs as well. So but we don't need to know that. All you need to know is this basically, I guess, as far as the star and the plus goes. For anything else, please refer back to the lecture recordings. I think that's pretty much all of it. So thanks for listening. Bye.